Okay, so in this video, I'm going to do some data analysis that is going to go along with the packet from lab called the Guide to Statistical Analysis and Practice Problem Set. And so I'm going to be solving for some basic descriptive statistics in this video. I'm going to show you both how to do it by hand, and then I'll show you how to have Excel calculate these for you. And so just some background knowledge that we'll need to get through this data is we need some information about the data itself. And so scientists in this particular study, they were trying to test whether or not low doses of antibiotics, in this case penicillin, has an effect on the natural microbiome of the gut of these mice. And so inside of mice, there is a particular bacteria called lactic acid bacteria, or for short we call it LAB, L-A-B. And that particular bacteria is found in the gut of mice, and it's part of their normal natural microbiome, their normal flora. And so the question again is asked, if these mice are exposed to low doses of antibiotic, over time is that going to change the number of bacteria, this particular bacteria, LAB bacteria, found in the gut of these mice? And so this was a nice controlled experiment. Researchers had two groups. There was one that was the control group. The control group of mice, there's 5 of them in that group, and those mice did not receive any antibiotic. Okay? The other group, which is the other 5 mice, they're going to be our experimental group, and those mice are going to be exposed to low-level doses of penicillin, that's our antibiotic. And what the researchers did after they either exposed or didn't these mice to antibiotic, is that they came back and they looked at fecal samples from both mouse populations, and they tested for the amount of bacteria present in both populations. And so again, for both the control as well as the experimental group, there were 5 mice in each group. Okay, so let's do some analysis. The first thing that we should do is come up with a null hypothesis and an alternative to that null hypothesis. And so in this packet, that would be on page 3. And so a good null hypothesis here would be that the antibiotic penicillin at low doses over time should not have an effect on the microbiome, and therefore the levels of LAB, lactic acid bacteria, found in these fecal samples from mice, there should not be any difference between the experimental and the control group. Where the alternative to that hypothesis is that there will be a difference, right? So there will be a statistically significant difference in the level of LAB bacteria if we compare the control to the experimental group. Okay, and so that's what we're testing here. So on my Excel spreadsheet up here in the left, you can see this is right from the packet, the same data. So mouse number 1 through 5 for both the control as well as the experimental group. Okay, so again, the control group was treated the exact same way as the experimental group, except for it did not get the antibiotic, which in this case is penicillin. And so when we look at these numbers here, these are number of bacteria per microgram of feces times 100 million. So these are actually much larger numbers, but we've got them written here for simplicity's sake. So in our control population, you can see mouse 1 had 8.13 micrograms of bacteria per feces, mouse 2, 9.78, and so on and so forth. And then for our experimental, which again is the penicillin group, I'll actually put right up here, experimental. Oh, it went down there. Okay, so that we know that there is a control and an experimental group. Okay, so again, the experimental group was exposed to penicillin. And so what I'll start off by asking you to do is to just go ahead and get the sum total for each group. So you can take your calculator and you're just going to add up these numbers under control. So 8.13 plus 9.78 plus 7.54 plus 9.25 plus 8.38. Okay, so if you can go ahead and just add those up. And again, you would do the same thing on this side for the penicillin group. So just go ahead and add those up. And if you're not done yet, just pause me and go ahead and get those numbers. The next thing I'm going to show you is how to get a sum value using Excel. Okay, so again, we're going to be using Excel throughout this semester, so it's nice to get comfortable with some of these formulas. And so all I'm going to do in this first column under control for my total, I'm going to put equals, and then I'm going to write sum. Okay, and so sum, you can see if I hover over this, this particular function in Excel adds all the numbers in a range of cells together. That's what we want this to do. So I'm going to go ahead and I'm going to double click on that. And now I need to tell Excel what exactly am I getting the sum of. And so I'm just going to take my pointer and I'm going to highlight the numbers that I would like Excel to add up for me. So I did that. I want it to add up cells B3 through B7. And the last thing I have to do is put a little end of parentheses here. So to add the end of parentheses. And then I could just hit enter. And there's my sum. Hopefully that's the same number that you got. So for my experimental group, again, I'm going to hit equals, SUM, double click on that. And I'm going to highlight my numbers just by clicking on them and dragging. And then I'm going to put an end cursor there. And then I'm going to just hit enter. Okay. So there is my sum for both. So that's pretty easy. The next thing I'm going to ask you to calculate is the mean. Okay, so we're going to use the sum to calculate mean. And so mean is going to be the sum of those values divided by the number, in this case, the number of mice used in the study. And so for my control mean, I would do 43.08 divided by 5, because there's 5 mice. Okay, there was 5 different numbers that we added up there to get that sum. For my penicillin side, I'm going to do 22.29, again, divided by 5. So my sample size is 5. We use the letter N, so N represents, N equals sample size. Just so that you know, that's the letter that we use to abbreviate that. Okay, so again, you can do that by hand. Go ahead and do that. And again, pause me if you need to. I'm going to show you how to do that on Excel, a little shortcut for you. Okay, so again, after this week, we'll start to do things just on Excel. We won't have to do any calculations by hand. So this is pretty easy again. So I'm going to put in a formula. So I'm always going to start with my equal sign. And I'm going to put in average. And so the mean and the average are really interchangeable. And so average right there. Okay, my first one, double click on it, and I'm going to tell it what I want it to average. So these numbers right here. So I want the average of the control mice. So that would be cells B3 through B7. I just took my cursor and clicked on the first one and dragged. And then I just need to do an end of parentheses and an enter. Okay, so that will give you your mean or your average for that control group. And I'm going to go ahead and I'm going to do the same thing for my experimental group. And so again, equals AVERAGE. So this right here. And I'm going to go ahead and highlight my numbers and the parentheses and my equal. So there, I just calculated my mean value. Excel did it for me, right? So if you're doing it by hand, you can double check your work by plugging these into Excel. It's very nice. The second number that we're going to calculate is going to be the variance. And so this is a little bit trickier. And so on page 4 of that packet, I provide you with 2 tables, one to calculate the variance of your control population, and a second to calculate the variance of your experimental population. And so we need to calculate variance before we can calculate standard deviation. And these numbers tell us how spread out our data is. So how spread out the difference in your data. So it shows that. And we're going to use standard deviation on our graphs. We're going to put in standard deviation error bars to, again, show the spread or the variation in our data. Okay. We will be graphing our mean with standard deviation error bars. And so we have to get these numbers. And so let's do our first table here. So in this first column of the table where it says XI, this is just where you want to put in the value. So it's literally these same numbers. So I'm going to actually just do a copy and paste. Copy. Okay. And the same thing over here for my experimental. I'm just going to take these numbers and I'm going to do a copy. Okay. So in your table, you just need to rewrite the original data from that first table into that first row. And so what you're going to do now is you're going to find out what is the difference between that value and the mean value for each mouse. And so let's go ahead and plug that in. So my first number again was 8.13, and from that I'm going to subtract the mean from my control group. So that's 8.616. Okay, and I'm just going to keep writing that all the way down. 9.78 minus, I'm just going to copy this to make it easier. Ooh, maybe not. Copy. Well, let me do it. Okay, I'll have to keep rewriting it. I'm sure there's a shortcut, but let's just rewrite it. 8.616. And then we've got 7.54 minus 8.616. 9.25 minus 8.616. And lastly, 8.38 minus 8.616. Okay, and so you're going to do this math. So again, for the first one, you'll do 8.13 minus 8.616. And then what you're going to do here in this final column is you'll take the answer to that and you're going to square it. Okay, so you can go ahead and kind of do that math, and I'll plug these numbers in. So again, my first number is going to be 8.13 minus 8.616 squared, and that should give me 0.236, if I did that math right. My second number will be 9.78 minus 8.616 squared, which I believe is 1.355. Oop, wrong. 1.355. There we go. And the next one, 7.54 minus 8.616 squared should give me 1.158. And 9.25 minus 8.616 squared will give me 0.402. And then lastly, 8.38 minus 8.616 squared will give me 0.056. And hopefully I did that math right. Okay, and so in this next cell, so cell I8 where I am, what I need to do here, I use this formula. And so this symbol right here, it looks kind of like a capital letter E, but it's the Greek symbol. That stands for sum. And so I'm going to sum or add up the values that I just calculated. So I'm going to take all of these and add them up. Okay, so you can do that on your calculator. In Excel, I would just do equals sum would just highlight my cells, end of parentheses, enter. Okay, and so the sum value there is going to be 3.202. And then to get variance, what I have to do then is divide this number that I just calculated by n minus 1. And so what is n again? N is the sample size. And so we already said that the sample size here is 5. And so 5 minus 1 is 4. So I would divide 3.207 divided by 4, and I should get the answer of 0.802. Okay, so that is my variance. Okay, the other way that I could have gotten that, if I come over here underneath mean, I could just plug this into Excel like this. So equals VAR, and this is, I'm going to select VARS. And if you look, the explanation is next to it. It says estimates variance based on a sample. And so we have a sample of 5. We're not dealing with an entire population. We have a sample of the population. And so I'm going to double click on that, and I'm going to highlight my numbers, end of parentheses and equal, and it's pretty much the same thing, right? So 8.0163 is the same thing. I just rounded up here, 0.802. Okay, so again, you can do it by hand, or you can just, kind of plug the formula into Excel and it will do it for you. And so let me come over here really quickly and plug these numbers in. So this is going to be 5.43 minus the mean for the penicillin group is 4.458. Okay, so again, 4.22 minus 4.458. And 5.1 minus 4.458. 2.87 minus 4.458. So again, I'm just taking each number here and subtracting from it the mean. And the mean we know for our penicillin group is 4.458. Okay, so my last number here, 4.67 minus 4.458. Okay, and so again, the same thing I did over here with my control. I'm going to take the difference here, so 5.43 minus 4.458, and I'm going to square it. And so if you plug that into your calculator for this first number, it should be 0.945, 0.057, 0.012, 2.522, 0.05. Okay, and then again, here in this cell, we're going to use this formula, and so I'm going to take the sum, the sum of the values that I just calculated. So again, to get sum, I'm going to do equals, SUM, double click on that, select my data. I want the sum of these values, end of parentheses, enter. Okay, and then again, to get my variance, I'm going to take the number I just calculated, which is the sum of those, and I want to divide it by n minus 1. So again, in this case, my n is 5, and so 5 minus 1 is 4. So I'm going to take 3.981 divided by 4, and that's going to give me 0.995. And we'll double check our math. So I'm going to come back over here to this cell, and I'm going to let Excel do the calculation for me. So I'm going to say equals variance with the sample variance. I want to know this data right here, what's the variance of this data? So I highlighted my numbers, I put the end of parentheses, and enter. And look at that, same number, 0.995. Okay, so again, the quicker way to do it is to use Excel. We'll do it by hand just this first time, just to understand the math behind it. But again, Excel can do the math for us. So to get standard deviation, it's pretty easy. You are going to take the number that you just calculated, so 0.802 for my control group, and I'm just going to here use this formula, and I'm going to take the square root of it. Okay, so that's it. Just take the square root of that. And so the square root of 0.802 is 0.895. Okay, so all I did is I took this number and I square rooted it. Let's see if that's correct. So I'm going to come over here to standard deviation. And again, I'm going to let Excel do the math. So I'm going to do equals STDEV. Here we go. S. And again, I'm going to collect my data here. End of parentheses, enter. Yep, perfect. Okay, and the same thing over here. So again, if I'm doing the math myself, I would take 0.995 and I take the square root of it. You should get 0.998. We'll double check our math. So again, for Excel, I'm going to say equals STDEV, and is this the right one? Let's see. Okay. Yeah, so my numbers are the same. So 0.998, right, and 0.998. Okay, so again, you can calculate mean, variance, standard deviation. Those are 3 types of descriptive statistics. You can calculate them by hand using the formulas that we've provided for you. And again, at this point, hopefully you are learning how to figure those out and calculate them using Excel. Okay. In the next video, I will show you how to create a bar graph, and then I'll show you how to get your t-statistic.